Coming up, science, technology, engineering, and math are at the forefront of education today. But what about the arts? We'll discuss the state of STEM education and the movement to integrate the arts. Then we'll take you inside our 3D design and printing lab to see how Prince George's Community College prepares students for this rapidly growing field. Next on Around Prince George's.
Welcome to this edition of Around Prince George's. I'm Charlene Dukes, president of Prince George's Community College. Did you know that according to the U.S. Department of Education, only 16% of American high school seniors are proficient in math and interested in a STEM career? Yet the jobs of tomorrow will require in-depth knowledge of science, technology, engineering, and math. That's why President Obama has made STEM education a national priority. Here with me to discuss this important topic is Dr. Christine Barrow, Dean of Science, Technology, Engineering, and Mathematics at Prince George's Community College.
Thank you.
So, Dr. Barrow, let's talk about your interest in STEM. When did it begin, and how did you get to where you are with us today?
So it began probably when I was in the 9th grade with a really motivational biology instructor who made the topic so engaging and interesting that it made a big difference in my interest in pursuing it, such that I continued with that interest all through high school and college, ended up getting my bachelor's degree in biology, doing research all along the way, summer research programs in high school while in college, and again, that helps keep you connected to it, such that I ended up getting a PhD and realizing that I really love teaching, and so that's how I ended up here at the college.
Well, talk to us about what's the required education and training for most STEM fields?
So it depends on the STEM discipline. For a lot of the IT disciplines, certifications and IT credentials are really important. For other disciplines, a bachelor's degree or associate's degree or a bachelor's degree are fine for those disciplines. If you want to teach, if you want to do some of the other things, then master's degrees and PhDs are better. Some research programs as well require master's degree and PhD. So it just depends on the interest area.
And then if we can get a little more specific, what about particular courses?
So if you're looking at IT disciplines, then the courses that you need to be taking depend on what area of interest you have. Because the IT area and really the STEM fields in general are very broad and diverse. You're going to be trying to take courses that give you a good broad foundation, and then as you progress through your academic program, you're taking more courses that are specific to what you're actually interested in. So in my case, when I was studying the general disciplines of biology, as I got to my junior and senior year in college, I started taking more of the molecular genetics, which is what I was actually interested in. So it just varies depending on what you're interested in. You start off with the broad, and then you get to the more specific courses later on.
So are there any particular challenges that you think are prevalent, especially today, related to STEM education?
So based on some of the statistics that we've seen, math is one of the biggest challenges that students have for their interest in STEM. They don't see themselves being able to complete the mathematics requirements for them, for those disciplines, but realistically, most of the students with the right support system are able to achieve in mathematics. They just have got to have the encouragement, the positive feedback, and some of the support systems that they need. So math is a really big one. And then the other thing is the image for STEM disciplines. They either have an image of being kind of on the nerdy side, or they have an image of being kind of on the boring side. And realistically, it just depends on what your discipline is. That's the same for any area, whether it's STEM or some other area. You know, some of them are going to be more exciting careers than others. And so
well, you know, you hear a lot these days where these sort of sayings or cliches. It's you know, cool to be smart.
Yes.
And even I think Phi Theta Kappa, the community college's National Honor Society, has adopted a Nerd Nation,
absolutely,
kind of logo, so that we do understand that being smart is okay, and certainly
Yes.
being proficient in these areas are what we need
Yes.
in today's world.
And whether you're interested in STEM or not, being proficient in these areas is important because it helps make you an informed citizen as well. And so we want students to understand, certainly I'm always going to encourage you to pursue a STEM discipline, but even if you're not pursuing a STEM discipline, being proficient in these areas is really important.
And then, so how do we as educators help our students and even parents understand how important it is to be motivated early in
Yes.
one's probably pre-K-12?
So I think a lot of it is about the exposure that they have. So early exposure as much as possible to those STEM disciplines, making it engaging as well is important. So we need the parents to read to the kids as well, so that they know what's out there, so that they're exposed to this. Let them watch the news. Let them watch shows like Mythbusters and things like that that make the science, the technology, engineering, and mathematics, they make it relevant to the students so that they can get that early interest. And as much hands-on as possible, it really helps in the long run. I think the other thing that really helps when we're looking at STEM disciplines is making sure that we let the students know that it's okay to stretch outside of their comfort zone. Because when you stretch outside of your comfort zone, you're much more likely to discover something new and different. Mm-hmm.
I don't know today if there are many disciplines where having some that don't have a connection to STEM in some way.
Absolutely.
But we know that the future of at least America's economy, if not the global economy, is connected to STEM-related careers.
Absolutely.
So what are some of the occupations that you know about with the most employment and sort of job outlooks?
So some of the ones with the best job outlooks, I know you've heard me mention IT a couple of times today, but IT is really one of the ones that's greatest, and that's information technology, particularly software application development. I mean, we all have mobile devices, and so the apps that are running on those mobile devices and on our computers, that's where a lot of the time, jobs, and money are going to be in the future. Civil and mechanical engineering, those are very important disciplines as well. And of course the sciences. There's always a need for the sciences because the sciences are how we train our healthcare professionals.
And I know that in many institutions, and when I'm talking educational institutions, whether they are K-12 or even higher education, that there's a dearth of faculty and professionals who want to teach in those areas and commit themselves to education and lifelong learning, as you indicated before.
Right, and it's really important to make sure we've got really good professional development opportunities for teachers and faculty at all levels, because that's what helps keep them interested or gives them the initial interest in teaching. So we've done a couple of programs here at the college that have really helped to encourage students to consider teaching as a career. And then some professional development activities with our county school system partners to help the teachers who are currently in those areas to kind of know a little bit more and go deeper into those subject areas. And I think that helps a lot.
That's great to know. And I think the other thing is that as we think about students completing in STEM, are there particular initiatives or avenues that you believe as an educational institution we should undertake to ensure that students complete?
Yes, I think that a big part of what we should be doing is reaching the students earlier. That's why some of our partnerships in terms of dual enrollment have been critical at helping us to shore up the STEM pipeline. So when we do dual enrollment, there's a number of different ways that we can do it. There's a traditional model where we're just reaching out to the high school juniors and seniors. These are the students that oftentimes are prepared for some additional challenges in their education. They just haven't had that opportunity yet. And then there are some other programs that are a little more innovative, where we're talking about early college experiences starting at the 9th grade.
So what we'll do is, why don't we come back in just a few moments, and we'll continue this discussion about dual enrollment and starting in the 9th grade. Let's take a short break. We'll be right back with more on STEM and the new trend towards integrating the arts.
When you throw away money on wasted electricity, you're throwing away everything you could have bought with it. Saving energy saves you money. Learn more at energysavers.gov.
Oh, prime time. We are rolling.
All right, Mama's gonna bring it home. Mama's gonna bring it home. Okay.
Come on, watch this guy.
Oh, backwards.
Oh, don't. Oh,
It went into Bob and Carol's yard. Oh, no? Okay, here it comes.
oh no!
Challenge your kids to be active and eat healthy.
All right, let's see what you can do. Let's go.
They might surprise you.
Let's go.
Search We Can for more ideas on how you and your kids can get healthy together.
Welcome back to Around Prince George's. Let's continue our discussion of STEM, science, technology, engineering, and math education, but we also want to turn our conversation to the growing movement to infuse the arts and creativity into STEM by calling it STEAM. Joining me to add her perspective is Barbara Johnson, Chair of the Art, Music, and Philosophy Department at Prince George's Community College. Welcome, Barbara. And before we really talk about the A now in STEAM, I'd like to just follow up with Dr. Barrow and Christine and talk a little bit about the dual enrollment. We were mentioning that partnership with the Prince George's County Public Schools.
So we're doing a number of things with the Prince George's County Public Schools. The first and most important one for right this moment is we have our Academy of Health Sciences, which is our middle college. Which they take a number of STEM courses that prepare them not only for the health science disciplines, specifically the allied health disciplines, but also for the medical degree areas. And then we're also doing the in a partnership with the Chesapeake Math and Information Technology Academy, we are doing an ITech program, which is Information Technology Early College. So it's modeled on that Academy of Health Science Middle College, but it takes it a step further in a different direction in terms of the information technology disciplines. And then we're also starting some conversations with Microsoft and the county school systems on arts integration, which is one of the things that a lot of conversations and even a lot of funding is centered around right now.
So that takes us right to you then, Professor Johnson. Yes. So do the arts belong in STEM?
The arts belong everywhere. Everywhere. That's my belief. They certainly belong in STEM, but I think they actually belong throughout the educational system. I think they bring a breadth of thinking that's a little bit different. And if it starts early, it just becomes a part of who they are and their innovative qualities.
So when we talk about it being integrated across all content areas, you said you believe that it belongs everywhere. What do you think specifically when you say that it brings a different perspective or allows us to garner a different perspective when it's included in our education? What are those specific things that you believe that we gain?
I think one of the things that the arts bring is a totally different use of a part of our brain, actually, rather than thinking very linearly, like happens in the system. When you're in the arts, you're thinking more broadly. And when I say that, it's not you're thinking about the what if as opposed to the what is. You're beginning as a person to understand that when you start a process, there may not be an answer. See, there is no direct answer. And so you have to trust that the steps that you are taking to get a problem solved are going to be right, which actually they're not always going to be, are they? Sometimes you're going to take a misstep. So I think one of the big things we learn is not just how to think in a broader way, the possibilities out there, but also we learn how to fail. And that idea of failure, I'm not talking about total failure. What I'm talking about is if you're thinking innovatively, and that could be as simple as doing a drawing. You're thinking innovatively, you don't know where you're going. And you're going out there. Well, some of the times you're going to misstep. Say you're going to draw the wrong line. We talk about a piece of art. You're going to draw the wrong line. The idea is, okay, that isn't where I wanted that line, and so you go back and you come again to draw the line. And you do it until it's right. The difference in that is, if you fail, And believe me, you can paint all day in a studio and at the end of the day, take a knife and scrape it off. The big key is, do you get up and try again? And I think that that prevails through all disciplines that need. And if I had to say that I learned anything in college, and I learned a lot in college, I think it was learning that failure is not wrong, because what we do is we learn more from our failures than we do our successes. And so I think that's a really big learning curve.
Well, I certainly love the analogy that you draw the line. It may not be the direction in which you want it to go, but you really have the opportunity to erase it and start all over again. But in the process, think about what you're learning. So I really love that and appreciate that you laid that on the table for us. So as we talk about this whole notion of STEM and now STEAM, where we're incorporating the arts, and maybe it is this notion of failure and rethinking, revisioning, envisioning as we think about success for students. What are ideas or examples that the two of you could share about what we're doing today at the college that makes the connection between these very important content areas?
So we've already, like I mentioned, we've started a conversation with Microsoft centered around things like 3D printing, because a lot of what we do in terms of engaging the students in the STEM disciplines, as well as helping them to think creatively, is centered around making sure that they know how to take an idea from their mind and create something with it. So whether we're talking about simulation, visualization, or 3D printing, fabrication, that's one of the biggest things that we're doing right now in terms of the integration between the STEM disciplines and arts.
What I'd like to say is this has really been an insightful conversation. We want to thank you, Dr. Barrow, and you, Professor Johnson, for sharing your thoughts on this important topic. I think what's been interesting for me is how we combine the scientific method and the strength of the arts and arts education. So we're going to take a short break now, but when we return, we'll show you how Prince George's Community College students combine the arts and technology in our 3D design and printing lab.
Don't look at me. Your hair's a bit frizzy today. Oh, you should pick that up. Oh, you're such a dork. Loser. Here, let me help you with that. Oops.
Every day, kids witness bullying.
Oh, look. Your crush is looking at you. Poor you.
They want to help, but don't know how.
See, no one here's gonna help you, because no one
Teach your
likes you.
kids how to be more than a bystander. Visit stopbullying.gov.
Welcome back. When it comes to art and technology, Prince George's Community College is at the forefront of training students in 3D design and printing. Take a look.
Grids, vectors, three-dimensional mapping. This must be an engineering course, or maybe high-level mathematics? In fact, it's Art 2670, a Prince George's Community College class that introduces students to 3D design and printing.
It's the only process right now where you can take ideas straight from the computer and quickly make prototypes.
The printing lab's facilities attract a diverse set of students. Susan Svensson is a retired science teacher.
I've always been interested in the art of science. I come into it from botany and astronomy, chemistry, in the types of microscopes that they have, all available here at the Prince George's Community College.
So what I'm trying to do with this landscape here is create a number of objects that are tall and short.
Janelle Azor is a simulation and visual entertainment major at the University of Baltimore. She took her required 3D design class at Prince George's Community College and then found that she was getting a head start, learning state-of-the-art techniques.
You use a 3D scanner in order to scan like something that's, physical object that's already there. Or you can 3D scan a human, any object you want, and then produce this model in technology, in the programs that we have here, like Mesh, Mixer, NetFab, Sculptress, all of those programs.
These students get access to technology, supportive classmates, and a future-ready education.
I think this 3D printing is something that is going to change not just art and science, but also the whole way we manufacture things all over the world.
Joining me to tell us more about our 3D design and printing lab is Associate Professor John Anderson, Irv Salzberg, retired NASA engineer and current PGCC student, and Emmanuel Felipe, a current visual communication student. Welcome to each of you, and thank you for being here with me. Professor Anderson, we're going to start with you. Tell us, what is 3D printing? What is this all about?
Well, 3D printing is essentially printing an object. So if we think about how, if we're printing a document, say a Word document or an image document, the printer would work by depositing ink along an x-axis while paper is shooting through the printer on a y-axis. Well, with 3D printing, we'll take an object and we'll put that through the computer. The printer will read that, and so the print head will move possibly on the x or y axis, depositing a plastic onto a print bed, and that print bed may lower along the z-axis, building layer by layer the object that has been rendered. And so 3D modeling then would be a way to use software in order to create those kinds of objects.
So why is 3D printing so important in today's world?
It seems to be everywhere. We see cars that are being manufactured with 3D printing. We see that there are many things that are engineered that are no longer being produced with traditional methods. They're now being 3D printed. There are houses that are being extruded in China with 3D printers that extrude concrete. It's being used in ceramics. It's being used in architecture. So it's being applied in many fields. And so we're on the cusp of something new and great.
So we'll move to you, Mr. Salzberg. You're a current student, a retired NASA engineer. Why did you decide to enroll in a 3D printing course?
Well, primarily curiosity. The technology is new, and I didn't have any interface with it during my professional career. And I was really curious to see how all of this potentially very disruptive technology could end up being useful and how it would affect my life. So I wanted to get a little bit more knowledge concerning what was going on with it, and I found that here at Prince George's County.
So tell me, how do you envision, you've been an engineer, certainly working in a very prolific field, how do you see this 3D printing thing applying to the future? What are its future applications?
Well, it's very hard to say. It could be extremely disruptive in the manufacturing area, but right now rapid prototyping is where its mainstay is. The ability to be able to crank out intricate objects such as this in a very short period of time enables the engineer to integrate various products very, very quickly and very, very accurately before they go into major manufacturing.
So we'll go to Emmanuel. You're a current student here as well at the college, and why was 3D printing important to you? What is it teaching you?
Well, I learned a lot in 3D printing. I guess first and foremost, I would have to say that I learned the most through trial and error, because here at PGCC, during our course, we had 3D printers such as the Affinia and others that we use most commonly, the printer bot. And it was me and a colleague of mine who would constantly attempt to print an object or a scan or something. And it was through our constant failure that we kept on trying, and we learned a lot about how to properly print a 3D object and also the fundamentals of overall 3D printing.
So what do you plan to do with your training where you're combining this art and technology?
Well, I guess in my everyday life. For example, I ride my bike, and when I ride my bike, I like to listen to music through my phone, and it can be a little clunky in my pocket. Mm-hmm. So one of my ideas is to print out a mount for my phone on my bike. And granted, it would be a little bit of work, but it would definitely save me about 20 to 30 bucks. So that's a plus.
And so what do you want to do? What are your future plans in terms of your education and your career? Do you eventually want to be a college professor like Professor Anderson? Or move into something else?
Well, the possibilities are endless. You know, I'm just moving with what my gut tells me. Currently, I am on the journey to becoming a video game designer. It's what I want to do. It's my passion. I really doubt that'll change, but I mean, you never know.
All right, good. So, Professor Anderson, why don't you talk to us about one or two of the things that we're looking at here on display?
Well, one of the things that we talk about in the classroom is since we have such a small print volume, we have 4 cubic inches that we can work through. How do you make a big model? And so a few of these models demonstrate how we can take a scan that could be larger than the print volume. We can create some pegs and some holes. We could probably create some dovetail joints, and how to piece these objects together. And so within the course of the class, one of the things that we talk about is how do you take a model, how do you cut it up, how do you add these additional pieces so that they can be assembled together. And and you know, the same thing could apply for this gear that Irv was showing, in terms of how can you make this integrate with some other object, and you know, could we build machines?
Well, I think it's interesting because it also looks as though we have some profiles here, so that you could take a profile of each one of us. How does that happen? Do you take a picture, or do I have to put my face in something?
We've got a couple ways of doing it. On this campus, we've got a 3D scanner, which we can walk around an object or a person and scan their face. We could also use photogrammetry, which all we need is a simple point-and-shoot camera. And if we photograph an object from multiple angles, we can put that in software and render an object.
Wow, that's really interesting. I think that we have Mr. Salzberg, who retired engineer, lifelong learning. We have Emmanuel Felipe, who is a young student and thinking about his career and what all of that brings to us. And then we have you, Professor Anderson, who really has, you've brought some new technology and its combination of art and technology and design to Prince George's Community College, and we really thank you for that. So you're all doing incredible work in our 3D design and printing lab, and I want to thank you for joining me on the program today. Before we close, one of our graduating students will share how Prince George's Community College has prepared her for a career in design and technology. Join us next time for Around Prince George's.
College actually taught me everything that I know about digital art and everything. Okay, so this is called a 3D rig, where you take a model and put basically bones in him and make them move. Professor Anderson taught us how to make these buildings move along these paths. It's different than just regular art. It has its own world and its own place. I knew nothing before I came here, and so they really gave me a head start. I don't know what exactly I would have done if I had not come here and did the visual communication program.